Okay, hello friends, welcome to my YouTube channel, Paul Mathematics Academy. Now, in this video, we are provided with this series. Now, in this series, we are told to evaluate this. Now, we have the sum of n running from 1 to infinity of 1 over 3n factorial. So I will be using Laplace transform, so it will be easy for us if we use Laplace transform. So I can make a function. I can just say let's have the function of t, so that function of t will now be equal to sum of n running from 1 to infinity of t raised to the power of 3n over 3n factorial. Now, if I say that t is 1, so we have my initial problem. That was my original question. So now let's take the Laplace transform of both sides. So taking the Laplace transform of both sides, so I have the Laplace of f of t is equal to the Laplace transform of sum of n running from 1 to infinity of t raised to the power of 3n over 3n factorial. So don't forget that we are dealing with t, function t. So we take the Laplace transform of this t raised to the power of 3n. So I have Laplace transform of ft is equal to sum of n running from 1 to infinity of the Laplace transform of t raised to the power of 3n, everything over 3n factorial. Now I would like to recall this. We have Laplace of t raised to the power of n, so it will give us n factorial s raised to the power of minus n minus 1. So that is the Laplace transform of t raised to the power of 3n will give us 3n factorial s raised to the power of minus 3n minus 1. So our question becomes the Laplace transform of f of t so this will now be equal to the sum of n running from 1 to infinity. Now, instead of writing the Laplace transform of t raised to the power of 3n, so we are going to write 3n factorial multiplied by s raised to the power of minus 3n minus 1, everything over 3n factorial. So we can see clearly that 3n factorial cancel 3n factorial. So, and don't forget, okay, we can still factorize minus out, that is the negative sign. So I have the Laplace transform of f of t. So this will be equal to the sum of n running from 1 to infinity of s raised to the power of minus into bracket 3n plus 1. So let us quickly recall this. From the law of indices, if we have a raised to the power of minus n, it will surely give us 1 over a. So we are going to use it now. So s raised to the power of minus into bracket 3n plus 1. So this will give us 1 over s raised to the power of 3n plus 1. So according to the law of indices. Now, so I have my Laplace transform of f of t. So is equal to the sum of n running from 1 to infinity of 1 over s raised to the power of 3n plus 1. So I can factorize s out from this my denominator. So I have 1 over s multiplied by the sum of n running from 1 to infinity of 1 over s raised to the power of 3n Now don't forget that the sum of n running from 1 to infinity of 1 over s raised to the power of k. So this will surely give us 1 over s raised to the power of k minus 1. Now our k is 3n, so I have is equal to 1 over s raised to the power of 3n minus 3 minus 1. So sorry, n will be here. So my k is 3, so I have 3 minus 1. So my series becomes Laplace of f of t is equal to sum of n. So 1 over s multiplied by sum of n running from 1 to infinity of 1 over s cube. Sorry, so we are not writing sum again because sum of this will give us this. So I have 1 over s into bracket 1 over s raised to the power of 3 minus 1. So we can expand this. That will be 1 over s raised to the power of 4 minus s. So we have to take the inverse Laplace of both sides. So I have Laplace transform of f of t is equal to 1 over s raised to the power of 4 minus s. Now, taking the inverse transform, that is inverse of Laplace of both sides. So I have inverse of Laplace transform of f of t is equal to inverse transform of 1 over s raised to the power 4 minus s. So inverse of Laplace transform of f of t will give us f of t. So I have f of t is now equal to, now the inverse Laplace of 1 over s raised to the power 4 minus s is equal to e raised to the power of t over 3 plus 2 over 3 e raised to the power of minus t over 2 multiplied by cos root 3 over 2t minus 1. So my next video I will prove this inverse Laplace for you guys so that you can know how to find the inverse Laplace of any function. Now I say that from this function of ft, so I say that my t is what? 1. So at t is equal to 1, so I have f of 1. So I have f of 1 is equal to, so substitute t for 1, so I have f of 1 of e raised to the power 1 over 3 plus 2 over 3 e raised to the power of minus 1 over 2 cos of root 3 over 2 minus 1. So this is 1 over root e. So I have e over 3 plus 2 over 3 root e cos root 3 over 2 minus 1. So this is the answer. So if you like this kind of video, please don't forget to subscribe to my channel, like my videos, and share my videos to your friend who also like mathematics. I love you all. Thank you for watching, and God bless you all. Amen. Bye bye.